Welcome to the Data Future channel. This is Shekhar and I am a data scientist. In this particular tutorial, we are going to develop a machine learning model which can predict the weather. Uh, it's just like a weather forecasting model where we have to provide the attributes of the weather like different parameters like temperature, wind speed, pressure, dew point temperature, and the humidity, and based on that we can predict what type of the weather will be, whether it is a clear or cloudy day, whether there will be a rain or fog, something like that. Okay, so let's get started by using a Jupyter notebook. First thing what we have to do, so we have to import the required libraries. I'm importing here the pandas, numpy, matplotlib, and seaborn. So matplotlib, seaborn are the data visualization libraries. Pandas and numpy are the data manipulation. So next step is we have to load the data. So here is we are using um, data by using pd.read underscore csv. We can read the data. So here we can see the first 5 rows, and there are columns: date and time. So we are recording these parameters every 1 hour, and temperature, dew point temperature, relative humidity, wind speed, visibility, and pressure. And here is the weather. So out of this, I think weather column is the categorical one. Let's get see what is the number of rows and columns. So 8784 rows and 8 columns in the data set. This will give you the list of columns, the data dot columns, because I have created data as a variable here. So data dot d types gives you the what is the data type in that particular data type of these columns: date, time, dew point, relative humidity, wind speed, visibility. Okay, and we can check the information, data information. So here 8784, these records, non-null records, means there is no missing values. This is the data type of each column, and this is the columns. Okay, now we can check what type of the weathers are there. So I'm using data dot weather dot value counts. So what it will give you, so it will give you different weathers. Now you can see out of 8784 records, these records are having a maximum number of categories of weather, but there are some weathers are appearing one time, which is not good for the model. So we have to standardize these categories and convert these all categories into 3 to 4 categories. So for that, what we have to do, so you can check how many unique uh, weather categories, and total number of this is by using unique and ununique. Okay, now I want to convert these categories into a standard one, and we will select only 4 categories. Okay, so I'm selecting here the first case. How we can do that? So for that I'm considering this case here, copying this and using this, and I'm creating a list of lists. So it will split it into a split it in by using a comma, and split it by using this space. So here I'm using a list comprehension. You can see there is a list of list here. Now I want to flatten this list by using a iter tools module, and I have to import the chain function, and so I can flatten the string here like this, and then I have to check whether there is a rain inside this, then it will be a rain, fog inside this, then it will be a fog. So for that I have written the two functions. One is to create a list of this the weathers inside this, and I want to convert these weathers into a standard category. If it is fog and rain, then it will be fog plus rain. Snow and rain, then snow plus fog. Snow and rain, then it will be snow and rain actually, not fog. Okay, snow and rain. Okay, snow and rain or rain and fog. Snow, shower, snow. Okay, rain, snow, fog. Everything is there. Okay, fine. Snow and rain. So it should be a capital one. Okay. So I'm converting into a standard categories. So you can do it like this. And I'm applying for this X actually. So X is here. So I'll apply this first function which I have created. Then I will apply this second get weather and supplying the list here. So it will convert rain plus fog because there is a rain and fog is here. Okay, so I want to apply this on this data set for this, and I will apply this on the weather column by using this lambda function, and I'll get a new column that is standard weather. You can check these are the new categories. The fog, freezing, drizzle, fog is converted into fog like this. Now you can check the rest categories. Now here you can see there are categories which are again 7 categories still there. But we have to consider only first 4 categories which are having a maximum records, and for that what I'll do, so I'm considering these things. First thing is first thing is okay. So I have to create here this standard means balance this data set considering this only 4 categories, and for that what I'll do, so I'll select the cloudy weather. So data is in square bracket data standard weather is equal to cloudy. I'm considering this. Okay, and yes, you can see that uh, okay, here is uh, the cloudy df. Okay, cloudy df is this, and having 3797 records. So here I'll use the sample and I'll consider only how much. It's around 600 records out of this cloudy. Okay, then you can see 600 rows are selected. Now this data set is ready for the cloudy df. The same I'm applying it for the clear. So I'm selecting 600 records. Here you can see 600, and because we are having 600 and 556, so we want the balanced data set. Okay, so for rain and snow I am using this. Now these data sets are there. So rain it's a 603 and snow is a 556. Okay, now here also I can show you what is the shape of this. Yes, 600. Now I have to combine this all the data sets here. So how to combine that? So for that, I'll use the concat function, and I'm providing the all these four data frame list of data frames, and providing the axis is equal to 0 means they will stack on one another. So it will create a new data set, that is the weather data, and its shape will be the addition of these four. Okay, 556, 603 and 1200. Okay, now we are having a new standard weather. This is old one and this is date time. So date time and weather, these old columns are not required. So what we can do, we can remove that. So before that, we can check the new standard weathers. Now you can see this data is quite balanced one. Okay, the rain is 603, cloudy is 600, clear is 600, and snow is 556. Okay, so I want to drop this column weather and the date time, which is not required. So for that weather df dot drop, I am using the list of columns. Axis is 1. In places 2 means from this existing data frame. So when I run this and check, yes, now our data frame is ready. Now we have to check the duplicate here, whether there is any duplicate values. Whether df dot duplicated, we can do, yes, there are no duplicates. We can check, is there any missing value. Already we have checked, there was no missing value earlier. So here also there is no missing value. Whether type is everything is numeric, only one column, target column is string one. So we'll do some data exploration, and for that what we can show, whether df dot describe, so it will give the statistics of these columns, numerical columns. You can see the count is same, meaning value for each column, standard deviation, minimum, maximum, and these percentiles. Okay, these are the numeric columns. So we want to check the correlation among these features. So whether df dot columns, because it will give the correlation among the numerical columns only. You can see that numeric columns only there is a correlation. Highly correlated columns are temperature and dew point temperature. Is it's a dry bulb temperature and dew point temperature. Okay, this one. So we can plot the heat map of this matrix, correlation matrix. So you can see the nice graph, heat map here with correlation. But this data is not correlated except this dew point and temperature. Okay. So this is the columns. Now I want to plot some of the histogram and box plot here. So for the temperature, what I am using, the data frame temperature dot plot kind is equal to hist. You can plot the histogram here. The same thing is here. Then relative humidity you can plot. So it will give the distribution simply. So here is the relative humidity means 80% is data. 80 percent is the maximum humidity with frequency. So maximum data is available for 80% humidity. So wing speed you can check, visibility also. Is the maximum visibility for 30 kilometers, 28 kilometers I think. Then you can plot a box plot here for this to check there is any outliers. Yes, for visibility there is outlier. One outlier is there. Their outliers are there also at the bottom. You can check it for the wind speed. So wind speed also there are outliers here you can see. So you can do it for rest of the columns also. Okay, like pressure and temperature. Okay. So label encoding we have to do because the standard weather column is the categorical one. So we have to convert that categories into numbers. So for that I am importing a label encoder from preprocessing and creating object of label encoder here, and I'm fitting, so I'm converting this category column into a numeric one like 1 2 3. So standard weather column, and I'm fitting this label encoder to by using a fit underscore transform to the same this thing column. I will see the classes are, this is clear, cloudy, rain and snow. So this is 0 1 2 3. Now check whether this is transformed. Yes, it is transformed. Now this column is transformed. Weather, standard weather. We can check value count, the same value count, but in numbers. Okay. Now next thing is we have to convert this into a dependent and independent one. So x is nothing but these are the x values, means independent variables, and standard weather is the dependent, that is target variable. So x value I am selecting by dropping the standard weather. So I am having the x values, means x data, and y is the target data. The target is this weather. Okay. Now we want to do the scaling, feature scaling here, because these all the scales are different. The scale of this pressure is different, visibility is different, wind speed. So we have to bring them on the same scale. So for that I am importing standard scaler from the pre-processing, sklearn's pre-processing. So I am creating the object of standard scaler, that is yesterday scaler here, and I am fitting the data, x data, to this standard scaler by using a fit underscore transform. And now you can see our data look like this, means this is the standardized data, and we have brought this data on a same scale. Now splitting the data by using a 10 test split, I'm importing it from model selection, then create a xtest, extend xtest, ytrain ytest, and 10 test split x standard, and y test size we have to define 0.2, means 20% data for the testing and 80% is for training. Random state is 42. Then you can check the shape of this. So this data is used for training and this is used for testing. Then the next stage is model building. So I am building a first decision tree model, decision tree classifier, by using sklearn.tree import decision tree classifier, and creating the decision tree model by using this classifier. So I'll feed this data model to this extend ytrain by using dot feed function. So this is the training phase of the model. Now I am predicting the model. So this model dot predict x test, and whatever it will predict is nothing but the y predictions predicted by the decision tree. So y prediction dt. Now we have to check the model accuracy or the performance. So for that I need to import some matrix. In that first one is the accuracy score, classification report, confusion matrix. I am importing from the sklearn.matrix. Then the accuracy score will be y test and y predictions. Y test means actual values, y predictions means the values predicted by model. So here we have predicted that. Y test is already available with us. Accuracy is 61%. So accuracy is not that much good because the data is not standardized, because we have created the categories out of the data, and data was imbalanced earlier, but we have made it balanced. Okay, we can check the classification report, means you will get the overview of precision, recall, F1 score for these all the categories, and finally the accuracy. There is a lot of variation in the 0, 1, 2, 3 categories. So there is a need to improve the model. So confusion matrix is n by n matrix. You can see here by using a sns.heatmap, you can create a confusion matrix by using this object. So these are the correctly classified, that diagonal values, and rest of the values are misclassified. So we will build multiple models and check the which model is working best. So for that I'm using decision tree, random forest, support vector classified, k nearest classifier, logistic regression, and Gaussian naive Bayes. 1, 2, 3, 4, 5, 6, 6 models I am testing. I'm creating object of each model. I'm creating a list of this model, and I'm using a for loop to fit each and each model and predict and check the accuracy of this model. And I'll append this accuracy into this list, that accuracy list. Now the list of accuracy list is ready. You can see 68% is the maximum accuracy for second model, means for random forest. We can create a data frame of this, so model and its accuracy. So best working model is random forest, I think. Okay, we can use the K4 cross validation to check our output and considering the random forest model. So for that I have imported cross val score, and for cross val score I'm using model, then S, X, Y values, CV, and scoring is the accuracy. So it will check for the 5 different training and testing data. Now we got this. These accuracies are changing. Now what is the mean value of this? Is 61% accuracy, which we got for this thing. Um, for decision tree also. So we'll do some hyperparameter tuning here by using a grid search CV. So here I'm using a grid search CV and randomized search CV, where I'm putting these parameters, and to check which parameters, best parameters we get for grid search CV. Estimator is random forest, param grid is parameters, and I'm creating the grid search object. I am putting this model for X train and Y train. So it will take certain time because it will check all the possible combination of these parameters and will give you the best parameter with highest accuracy. Yes. Now I'll check what is the best parameters. The best parameters log 2 and estimator is 50. So I'm creating new model by using these parameters. I'll feed the data with new, and I'll check the accuracy. Here I'll use this model to predict here y. No, it's x test, right? And here is y spread by rf. I'll share, and then I'll check the accuracy of this model. So accuracy score will be y test and y predicted rf. So you can check this 67% accuracy. So yes, we can use the cross validation here for using this model, and we can check accuracy of this. So you will get the different accuracies here. 67 is the best accuracy. uh, no, here 61%. So our model is not working fine because its accuracy is 61, but we know how to develop the different models, classification model, by using this particular tutorial. So if we are having these parameters, then we can predict the weather also. We can improve the accuracy by using the some other models like gradient boost classifier or deep learning models also. So that's all from my side for this particular tutorial. Thank you.